Hey guys, today we're going to learn about atomic mass and atomic numbers. And this is the first lesson we're going to really get into what I think is the really good parts of chemistry, starting to look in a little bit more detail at the periodic table and what it's all about. So the periodic table, I'm sure you've seen this before. This would be an example of an element, a square from the periodic table. We have carbon, we have a number here, we have the symbol, the shorthand symbol for carbon, and then we have another number right down here. So the two things we're going to really talk about today are this number and this number. And right off the bat, this number here is called the atomic number. And then this is the atomic mass. Sometimes called the mass number. So starting off with the atomic number right here, this is the number of protons that an element has. So for carbon, then this is always the same. The atomic number will always be 6. Every single molecule or every single atom of carbon in the world has the atomic number 6, and that's just the number of protons that any given element has. So carbon has 6 protons. Number of protons. And every single atom of carbon in the whole world, in the whole universe, has 6 protons in it. So the number of protons determines what element an atom is. Any atom that has 6 protons is carbon. If it has a different number of protons, it cannot be carbon. And we can jump over here to the other examples. So the K is potassium. That has 19 protons. It has a mass number, or atomic number, of 19. And gold, Au, has 79 protons. It has an atomic number of 79. So all atoms of gold in the entire universe have 79 protons. If it has a different number of protons, it's a different element. This number down here is the atomic mass. And the atomic mass is defined as the number of protons plus the number of neutrons. Number of protons plus number of neutrons. And if you remember from the last lesson or a couple lessons ago maybe, in the nucleus there's protons and neutrons. Protons have the positive charge. Put down here, positive charge. And then neutrons have no charge. And then we'll talk about electrons in a minute or two, and if you remember, the electrons have the negative charge. So the atomic mass is just the number of protons plus the number of neutrons. Now they both weigh about the same. Mass, if you are thinking, oh, we measure mass in grams generally, so it's a weight. So protons and neutrons are about the same size. They have almost exactly the same mass, and we define one proton or one neutron as 1 when we're talking about atomic mass. So we have 6 protons, and if we have an atomic mass of 12, we know 6 of that 12 comes from protons, and so we know then that there must be 6 neutrons in this also. And to figure that out, you can always just remember the atomic mass minus the atomic number equals number of neutrons. So in carbon here, atomic mass, and we'll just round this, so let's say this is 12, minus the atomic number, which is 6, equals 6. So there's 6 neutrons in carbon, there's 6 protons and 6 neutrons. Now that's not always the case, as we'll see in a couple examples with potassium and gold. Sometimes there's a different number of protons and neutrons. Carbon just happens to have that 12 minus 6. We have 6 neutrons and 6 protons. Okay, so now let's move over to potassium and take a look at potassium. We have an atomic number here of 19 in potassium. So potassium has an atomic number of 19. It has an atomic mass, and again we'll just round this. So we'll say 39. And now these numbers aren't exact because in nature, some carbon atoms will have more than 6 neutrons, and some carbons will have less than 6 neutrons, and so some carbon might have an atomic weight of 13. There might be 7 neutrons instead of 6, and this is just the average weight of carbon. So you can see it's pretty close to 12, so the vast majority of carbon will have 6 protons always because of the atomic number, and then most of the carbon atoms will have 6 neutrons. Potassium, on the other hand, we have 19 is our atomic number, so it has 19 protons, and we have an atomic mass of 39. So let's figure out the number of neutrons in a normal atom of potassium. So we use our equation here, atomic mass minus atomic number. So atomic mass, 39, right? Atomic mass minus atomic number. Atomic number is 39. And that will equal the number of neutrons. And so 39 minus 19 is 20. So this has 20 neutrons. And it has 19 protons. And that's okay if there's a different number of neutrons. It doesn't have to be the same as the number of protons. And now let's talk about gold. So gold, we can see, look at this, 79 is the atomic number, 197 is the atomic mass of gold. So that, again, that's the average atomic mass. Let's say we have a gold atom though. Let's say this is a gold atom that has, let's pretend it has 200 atomic mass. Remember, this is just the average atomic mass. Some gold atoms will have a larger mass, some will have a smaller mass. Let's say we have a gold atom that has its atomic mass is 200, and we want to find the number of neutrons in this specific gold atom that has an atomic mass of 200. Oops. So again, we know the number of protons, 79, so we know the atomic number, and we know the atomic mass. Ours has 200, so atomic mass 200 minus the atomic number, 79, equals, and what is that, 121. So 121 neutrons. This, if we had an atom of gold with a 200 atomic mass, it would have 121 neutrons and 79 protons. Now, one last thing we haven't talked about yet is the number of electrons around all these atoms. So we know the number of protons, that's the atomic number. We can calculate the number of neutrons really easy with this simple equation right here. Right? So what about the number of electrons? For now, we're going to just think about electrically neutral atoms. So an electrically neutral atoms means just what it sounds like. It does not have an overall charge. So that means that the number of protons and number of electrons must be equal. Right? Protons have a positive charge, electrons have a negative charge. If we have the same number of each, the charges cancel each other out, and we have an electrically neutral atom. So for carbon, for example, we have 6 protons. If we have an electrically neutral atom of carbon, we know it must have 6 electrons. And if you remember, E negative is a very common abbreviation for electrons. Now that's not the case with all atoms. As we learned about ions, atoms that have a charge. So sometimes you'll get like Na plus. In that case, this has lost an electron. It's lost a negative charge, so now it has more protons than it does electrons, so it would have a positive charge. But for now, we're just thinking about electrically neutral atoms, which means if an atom is electrically neutral, it has the same number of protons as it does electrons. So an electrically neutral atom of potassium has 19 protons, 19 electrons. Gold, electrically neutral atom of gold, has 79 protons and 79 electrons. I hope that was helpful, guys, and that's all for today about atomic number and atomic mass.